Hello, this is Farhan Shakil from the Republic 2.0, and today we're going to talk about May 2025 Pure 1 Edexcel Maths paper. So the first question is that we have been given the value of P, that is 1 by 16 times x to the power of 4, and Q is 40 upon x cubed. And we just need to write them in the form of k x to the power of n, where k and n are fully simplified constants. Fully simplified constants are the key terms over here. So you've got p to the power of 1 by 2. So in the question number 1, you have got p to the power of 1 by 2. I'm just going to plug in the value of p, and that is going to be 1 by 16 x to the power of 4 to the whole power of 1 by 2, right? This power 1 by 2 belongs to both 1 by 16 as well as x4. So I can write it like 1 by 4 x square whole square to the whole power of 1 by 2. This 2 and 2 would get cancelled out, and you would have the final answer as 1 by 4 x square, right? Where k is 1 by 4 and n is 2 are the fully simplified constants. Now similarly, in the second part of this question, you need to times pq to the power of negative 1. So first of all, you've got pq to the power of negative 1. I'm just going to plug in the value of p, that is 1 by 16 to the power of 4 times 40 upon x cube to the power of negative 1. So first of all, I'm going to simplify whatever I've got in the brackets, and I would be having, 4 times 4 and 4 times 10, 2 times 2 and 2 times 5. This and this would get cancelled out, and you would just be having 5x divided by 2 to the power of negative 1. I need the power to be the positive, so I can just simply write it like 2 upon, I'm just going to reciprocate that, so 2 upon 5x. So that is how we're going to get ourselves the final answer of this thing. Now you've got the second C part, and in the C part, you need to times p by q square. So p is again 1 by 16 to the power of x to the power of 4 times q square. Q is 40 upon x cube, so 40 upon x cube squared. And now we would be having something like x4 upon 16 times the square of 40. The square of 40 is going to be 1600 divided by x to the power of 6. So now I would be having something like 16 ones are 16 hundreds are, and this would get cancelled out. So I must be having 100 upon x square. 100 upon x square, which can be simplified as 100 x to the power of negative 2. That is how we're going to write this thing, and for this one and for this one as well. Now, we have got this question number 2. In the question number 2, we've got a curve that is y is equals to 2x to the power of 5 by 2 minus 4x plus 3. We need to find dy upon dx, writing our answer in the simplified form. So for the A part, we are just looking for dy upon dx, right? So I'm just going to write my expression. It is being given that y is equal to 2x to the power of 5 by 2 negative 4x plus 3. I'm going to differentiate the expression on both the sides. So I would be having something like dy upon dx is equals to 2 times 5 by 2 times x to the power of 5 by 2 minus 1. Negative 4 times 1, and the differentiation of 3 is going to be 0. So now I would be having something like dy upon dx is equals to this 2 and 2 cancels out, and you have got 5x to the power of 2 times 1 is 2, 5 minus 2 going to be 3, so 3 upon 2. So I've got 3 upon 2 negative 4. That is the differentiation of the given curve. Now, the point P lies on the curve. The x coordinate of P is 2 to the power of k, where k is a constant. The gradient of C at the point P is 16. So if the gradient is 16, so what I'm going to do, I'm just going to plug in dy upon dx equals to 16 equals to 5x to the power of 3 by 2, take away 4. Since x was given as 2 to the power of k. That is the x coordinate at this point. I'm just going to work this thing down. 16 is equals to 5 times 2 to the power of k to the whole power of 3 by 2. Take away 4. And I'm going to swap this 4 onto this side. 16 plus 4 would eventually become 20. And 5 times 2k to the power of 3 by 2. And now I'm just going to simplify that. So 20 upon 5 is equals to 2 to the power of, I'm going to multiply this power with the power. So it must be 3k upon 2. And now it is going to be 4 is equals to 2 to the power of 3k plus 2. I can also write 4 as the square of 2, 2 to the power of 3k upon 2. Now we have got the same basis, so I can equate the exponents. So 2 is equals to 3k divided by 2, and 4 is equals to 3k. So k comes out to be 4 by 3. That is how we should look for the final answer for k, right? In the question number 3, we need to find the integral of this expression, and we need to write them in the simplest form. So first of all, I've got something like x plus 3 ka square, x plus 3 square divided by 3 root of x times dx. I'm going to expand the above expression. So expanding this expression, I would be having x square plus 9 plus 6x, right? Divided by 3 root of x times dx. Now I'm going to, write 3 root of x under everything. So I must be having x square divided by 3x to the power of 1 by 2 plus 9 upon 3x to the power of 1 by 2 plus 6x upon 3x to the power of 1 by 2 times dx. And now what I would be doing, I've got this expression, I'm going to simplify that. So it must be x square minus 1 by 2 divided by 3 plus 3x to the power of negative 1 by 2 and plus 2x to the power of 1 minus 1 by 2. Simplifying it further, I must be having something like x to the power of, 2 times 2, 4, 4 minus 1 has to be 3, 3 by 2 divided by 3 plus 3x to the power of negative 1 by 2 plus 2x to the power of half times dx. Now I'm going to separate out the integrals. So I must be having something like 1 by 3 x to the power of 3 by 2 dx plus 3 x to the power of negative 1 by 2 dx plus 2 x to the power of 1 by 2 dx. So simplifying it further, I must be having something like x 1 upon 3, applying the power rule of integration, 3 by 2 plus 1 divided by 3 by 2 plus 1. Similarly, plus 3 x to the power of negative 1 by 2 plus 1 and negative 1 by 2 plus 1 plus 2 x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 and plus the constant of integration. After working this thing down, I must be having something like 1 by 3 x to the power of 5 by 2 divided by 5 by 2 plus 3 times x to the power of 1 by 2 divided by 1 by 2 plus 2 x to the power of 3 by 2 divided by 3 by 2 plus c. So further simplifying it, all these denominators would get multiplied by the numerators. So I must be having 2x to the power of 5 by 2 divided by 15 plus 6x to the power of 1 by 2 plus 4x to the power of 3 by 2 divided by 3 plus c. So that is the final answer for this constant for this integration. Now we have got this question number 4, a very important question. We have got this curve, and this is the curve of equation y is equals to 4 cos x. So if this is y is equals to 4 cos x, the maximum value of y-intercept that we can have is going to be 4, and the value over here has to be negative 4 because, cos x ranges from negative 1 to 1, right? So 4 times negative 1 going to be 4 and 4 times 1 going to be sorry, 4 times 1 going to be 4, and 4 times -1 going to be -4. And now the maximum value must be at, this is x0. This has to be 90. This has to be 180. And this has to be 270. And similarly on the negative x-axis as well. The point P and Q lies on the curve are shown in figure 1. State the coordinates of P and the coordinates of Q. So first of all, if you're looking for the coordinates of P, x is going to be 270, and y coordinate, you can easily see that since it is the x-intercept, the y coordinate has to be 0. So the coordinate of P comes out to be 270 and 0 degrees. Now similarly, we need to talk about the coordinates of Q, this one. Y coordinate has to be -4, and if you're talking about the x coordinates, this is 0, this is -90, and this has to be -180. So it is going to be x is -180 and -4. That is how you're going to talk about the coordinates of Q. Now state the number of solutions of the equations 4 cos x to 3, 5 plus cos x is equals to 1 from this to this, and 4 cos x minus 3 is equals to 1. So first of all, if you think about that, remember that up till 0 to 360 degrees, this is 360 degrees, we've always got 2 solutions of cos x, right? So now we're just going to look at how many 360 degrees are there in these ranges. So we have got 0 to 18,000, right? So C first part. So 18,000 divided by 360 comes out to be something like 0, cancels out by 0. And then you've got 0 as it is, 1 and 2, and then 100. Yeah, it must be 50. So we have got 50 revolutions over here, right? And in one revolution, we've got 2 intercepts of x. So what does that mean? The total number of solutions? The total solutions comes out to be 2 times 50, and that is 100. So we have got 100 solutions of this equation from 0 to 18,000. Now for the second part, you have got 5 plus cos x. Same is the case with this one. In one revolution, we've got almost 2 solutions. So minus 720 to 720, it almost is 720 plus 720 is going to be 1440. So 1440 divided by 360 degrees comes out to be 4 revolutions. So if you have got 4 revolutions over here, the total solutions are going to be just 2 times 4, and that comes out to be 8 solutions. So we have got 8 solutions in this part. Now similarly, if you look into this thing, minus 1080 and 1080, we just need to find out the number of revolutions we've got. So for the C third part, 1080 plus 1080 has to be 2160, right? And how many intercepts, how many revolutions we've got? 360. So it must be something like 1 and 1 and 6 revolutions. And if you have got 6 revolution, and every revolution you must be having 2 answers of cos. So the total number of solutions that we can have are going to be something like 2 times 6, and that comes out to be 12 solutions, right? So that is how we're going to do the first 4 questions of this latest Edexcel exam. In the next video, I'll come back to you guys to start the paper from question number 5. Thank you very much. If you've liked the video, please share and subscribe.